Good evening, everyone. This is 2018 session paper. So we'll discuss how we can plan an experiment from paper 6. A student is investigating the factors that affects the size of a crater. A ball makes a hole when it drops into a sand. Plan an experiment which would enable us to investigate one factor which might affect the size of a crater. The apparatus available include a metal ball of different sizes and a tray of sand. Write a plan for the experiment. In your plan, you should state the factor to be investigated. So we want to investigate, it's up to you, any factor you can investigate. You can investigate the height, what is the effect of height on the size of a crater. Like you change the height from which the ball is dropped and observe how the size of a crater is affected by the change in the height. So the parameter which we want to invest either, or you can change the size of a sphere to compare the size of a crater. So the factor which we can investigate here, we can investigate the effect of height on the size of crater. State the key variable that we will control. So what we will control, amount of a sand and the size of a sphere which you are using, size or the mass of a sphere. List any additional apparatus what we need, because we want to measure what size of a crater is produced. So the additional apparatus what we can have, we can use a meter rule or meter scale to measure the size and from a height which is dropped. Explain briefly how would you carry out experiment, what would be measured and how this would be done. So what we will do, we'll measure the height and we will drop the ball or a sphere. Then we'll repeat the experiment with different heights and measure the size of crater by 2. Then state precaution you should take to obtain a reliable result. So because we are measuring the height, so we should avoid a parallax error. Precaution, so we have to mention at least 2. So we should avoid a parallax error. Parallax error due to the wrong position of eye, we may have a parallax error. What else we should do? We should avoid pushing the ball downward or forcing the ball downward, because that will also affect the size of a crater. So we should not push the ball or throw the ball, we just simply drop the ball. We should drop the ball instead of pushing it, otherwise it will affect the size of a crater as well. Then suggest a suitable graph that would you, so we can plot a graph between, because when we change the height, the size of a crater will change. So size of a crater is independent, dependent variable, and height is independent. So size should be there on size of a crater should be there on y-axis, and height from which we are dropping, that should be there on x-axis. So we will plot a graph, height on y-axis and crater on size of a crater on x-axis. So this was experiment from Feb-March session. Then we have another experiment from summer, May-June 2018 session that plan an experiment to investigate the size of air gap between a copper container and a large metal container on a rate of a cooling. So we have a large container and we place a copper container inside, and we are finding what will be the effect on rate of cooling for this gap size. So we'll change the following operatives available. There's a copper container, number of metal container of different diameters, all larger than the copper. So we have all large, and thermometer is there, stopwatch is there, measuring cylinder is there, and a supply of hot water. You can also use other operators and a material that are usually available in a school lab. In your plan, you should explain how would you carry out the investigation. So how we carry out rate of cooling experiment are always having a same trend. So what we'll do, like we'll take small container, we'll take a copper container, and we will add 10 cm cube water, hot water. Then we'll measure the initial temperature. After measuring the initial temperature, we will place the copper container into large container. Then we will measure the gap size. And record the temperature for 3 minutes with 30-second interval. Like after every 30 seconds, we'll measure a temperature, and then we'll repeat the experiment with different containers, different large containers, because copper container is fixed, only the large container we will change. To get the to change the air gap between the two type of containers. Then key variables which we will control. So surrounding temperature, lab temperature, amount of the liquid or volume of water which we are using, the initial temperature as well. You can mention many of them. Draw table or table. So whenever rate of a cooling we are observing, so we'll have and we can draw two different tables for different gap size. So here we have time and temperature. Here also we have time and temperature. Like example, this is gap size, say 3 centimeter, then this will be gap size 6 centimeter, and so on. And how would you use your reading to reach a conclusion? So we'll plot a graph to observe a rate of a cooling or effect. We'll always plot a graph between temperature on y-axis and time on x-axis, and the slope represent the rate of cooling. And the last one from winter session, a student investigating a relation between a power of electrical heater using a formula P equals VI. Plan an investigation to find a relation between power produced and a time for a heater, the electrical power produced by electrical heater and the time taken to heat a beaker of a water. The following apparatus available: ammeter, voltmeter, variable 250 cm cube beaker is there, a thermometer and a stopwatch. So the student have other apparatus available. Complete a circuit diagram to show a circuit that you will use. So we have a heater. This is a symbol for heater. Then to calculate the power of a heater, we need voltage and we need current. So to measure the voltage, we'll connect a voltmeter. And to measure a current, we'll connect an ammeter. Then the connection wires are there. There will be a switch. Then how would you carry out the investigation? So how we'll carry out the investigation, like example, we'll take 10 cm cube or take 20 cm cube of water. We'll measure the initial temperature. Then we'll place the heater, start the heater and the timer. And record the time to change the temperature by 10 degrees or 20 degrees, you can say. And then we'll read the voltmeter and ammeter readings. Then state key variables which we will control. So for this experiment, the amount of water which we will use, and we should repeat the experiment for different values of a voltage, because we are finding what is the effect of the power on heating. So we can change how we can change the power. So we can repeat the experiment with different voltage and current. So what we can do, like the variables which we'll control: the amount of the liquid, the water, the initial temperature, the final temperature, volume of the water, surrounding temperature, lab temperature, and the amount of the final temperature, initial temperature. These parameters should be constant. Then draw table, because what table we should have? We are measuring voltage, we are measuring current, and we are measuring a time. We can also calculate a power. We can make a column for power. So like we'll have voltage, we'll have current, we have power, and that time to change the temperature by 10 degrees. So voltage is there, current is there, time is there, or you can have a power here, P, which is watts, and then time will be there in seconds. Explain how would you use your result to reach a conclusion. So we will plot a graph between a power. Changing the power will change the time. So power should be on x-axis because power is independent. We change the power, the time will change, and time on y-axis. So we can plot a graph between the power n time to reach a conclusion or a result. So this was the experiment from 2018 session.